Okay, now that we've learned several rules in derivatives, let's move on to the sum rule. Meaning when you add two different things, what's the derivative of that? For example, f of x equals 3 plus x squared. F of x equals 10 plus square root of x. F of x equals 1/2 plus x to the negative 1/2. We're adding different terms. The real question is, what's the derivative of these things? Okay, how would we find f prime of x? So we're going to do another proof real quick. We're going to make a new function, call our sum function, s of x equals the sum of two different functions. For example, f of x could be your 1/2 here, g of x could be your x to the negative 1/2, or any of these things. In other words, the function is the sum. By the definition of the derivative, we have the following. So we're going to write s prime of x, the derivative of the sum of these, equals the limit as h approaches 0 of s of x plus h minus s of x over h. To figure out s of x plus h, we're just going to plug them into the original definition of the sum. So it would be f of x plus h plus g of x plus h. So this is going to be replaced with f of x plus h plus g of x plus h. This is going to be replaced with f of x plus g of x. So it's going to look like this. Okay? And so now what we're going to do is we're going to group the f of x plus h with the f of x and the g of x plus h with the g of x. Before we can do that, we have to distribute the minus. So it goes minus f of x minus g of x. Now we group the f terms together and the g terms together. And this is where it gets fun, because we can now take these two terms, divide by h to get this, and then take the g of x plus h minus g of x over h, split it up into two different fractions. And we're almost there at the end of the proof. Can you see now that this looks like the derivative of f, and this looks like the derivative of g? That's because that's exactly what it is. So we actually have two separate limits. Limit as h approaches 0 of f of x plus h minus f of x over h, plus the limit as h approaches 0 of g of x plus h minus g of x over h. Again, we can split this up into two separate limits. Because of the limit laws, we can make this two separate limits. If you have any questions about that, go back and look at the lesson on the sum of two limits. So anyways, now we have s prime of x is equal to what? Well, this is f prime of x. This is the definition of the derivative of f, so we're going to write f prime of x. And then we have this, limit as h approaches 0 of g of x plus h minus g of x over h. That's just the definition of the derivative of g. So we've proven, and basically, that when you start out with the sum of two different functions, f of g, all you have to do is take the derivative of f and take the derivative of g. And that gives you your derivative. So the derivative is just the sum of the derivatives. So it's real simple. There's your sum rule rewritten in simple notation. Just take the derivative of each function. It's intuitive, it's easy, and I really like the proof actually, because the proof's pretty simple. So let's do an example or two together. We have f of x equals 3x squared plus 7x. To find the derivative, we're just going to find the derivative of the first and find the derivative of the second and add them. We know we're using the sum rule because it's a plus. If you want to, you can still break it down so that you can see that you're also going to be using the constant multiple rule as well as the power rule. So we'll actually be using the sum rule and those other two rules that we just mentioned because of that reason. So, yeah, that's the power rule. All right, so let's go ahead and take the derivatives. The derivative of 3x squared and plus the derivative of 7x. Now, hopefully I've done this so much that it's second nature to you by now. But the derivative of 3x squared, the derivative of x squared is 2x. Multiply that by 3. And then over here, the derivative of 7x. We've already proven the derivative of x is 1, so it's just going to be plus 7 times 1. If you want to, you can read into this more, and if you have any questions about this, let me know. Finally, so 3 times 2x is 6x, and 7 times 1 is 7. So we get 6x plus 7. So this was our original function. We found the derivative of each component, and we just add them. That's the sum rule. Final answer, f prime of x equals 6x plus 7. That's it for the sum rule. And it can be more than two functions, actually. It works for 3, 4, 5, 6, 7. So it could be, what's the derivative of 3x cubed plus 10x plus 5? Okay, that's three different things, but you can still find the derivative of each of those things and just add them. Next up, we're going to learn the difference rule.